Here's our first flipped classroom, section 6.3 notes, day 1. Key vocabulary are the first 2 slides, and then we'll go into the rest of the notes. Here's the key vocabulary.
Alright, hi guys, so we're going to take you through the notes today at home, and then tomorrow you're going to work in groups on the homework assignment that you're usually doing at home. So I'm going to take you through the notes, so you should have those out following with me, and let's go into 6.3. So we're going to approximate square roots now. We're going to find square roots or radicals of non-perfect squares. So we'll look at 24 and 23 instead of the radical of 25. So our essential question, what are we going to walk away knowing from 6.3 is, how can you approximate a square root? So there are 2 vocabulary words that we need to know. A blank is a number that can be written as a ratio. We talked about this in class. It's called, and it helps us, that word ratio, it's called a rational number. So a rational number is a number that can be written as a fraction. So we're looking at whole numbers and integers and already fraction numbers as well. So a blank cannot be written as a ratio, and we talked about what 2 letters do we put before a word to be not that, and we call that irrational. The I and the R before a word means not, like irregular means not regular. So it's an easier way to remember what a rational number is and what's not rational, numbers that can't be written in the form of A over B. And there's 2 facts that we need to know. The square root of any whole number that is not perfect is irrational. So when we're looking at examples such as the square root of 25, 25 is a perfect square. So we know that the square root will be rational. But when we have something like the square root of 47, the square root of 47, 47 is not a perfect square. I can't think of a number times itself that will be 47. So I know that the radical of 47 is what an irrational number would be. Also, the second fact that we need to know, the decimal for an irrational number neither terminates nor repeats. So it's a decimal that goes on forever, such as an pi, 3.14, goes on forever with no repeats in there. So we're looking at non-repeating decimals. So if we look at the decimal conversion of 0.123, 123, 123, 123, since that pattern is repeating, it's considered rational because it repeats itself. Even though it's non-terminating, there's repeating in there. So it's a rational number. Irrational numbers are those numbers that never terminate and never repeat. They need to hold on to both. So now we should be able to classify any number that we look at as a rational number or an irrational number.
Part 2 of the key vocabulary terms.
Alright, now we're going to start talking about key vocabulary words that you might have just forgotten in the past. So I made a Venn diagram. Hopefully you remember that from elementary school. So we have, in 8th grade math, and in all of math, we have a universe. Think of it as a universe called real numbers. And within that universe, we have 2 subgroups. We have the rational number subgroup, and we have the irrational number subgroup. The 2 worlds don't collide, so you don't see the Venn diagram intersecting there. They are separate. So numbers in the real number system either fall into the rational circle or it falls into the irrational circle. So it says rational numbers and irrational numbers together form the set of what we call real numbers. And up until 8th grade, you've always lived in this rational set with a couple examples of the irrational world, such as pi. We all know that pi is the first one we come across that we're familiar with is an irrational number because it never terminates and it never repeats. You've heard your 5th grade and your 6th grade teacher say that to you. So rational numbers are broken up into more than 2 groups, but I really highlighted 2 groups. You have your rational numbers. Remember that word ratio is in there, fractional parts. So we have our fractions in there, positive, negative. We have repeating decimals. We have terminating decimals. And then within that, a smaller cluster is called your integers. Those are all of your whole numbers, 0, 1, 2, 3, 4, and so on, and they're opposites. So the negatives are in there too, -2, -3, -100, -1000 is in there. So those are your integers. And within that integer world, there's even a smaller group that's just your natural numbers, also called counting numbers. 1, 2, 3, 4, and only the positive ones. So our rational number system is broken into smaller groups, and basically that's how we learn math. We start with our counting numbers, and then we go to whole numbers, and we really increase increase that idea of mathematics as we progress. So 8th grade, one of our major curriculum goals is to move into that irrational world and really have you understand what that irrational world is about. So now from the last slide you just saw, video you just watched in the vocabulary, the radical of 2 is what we call irrational numbers now. Because 2 is not a perfect square, therefore we can categorize by looking at that radical that that's an irrational number. Also, negative roots are irrational numbers. So we have negative radical of 3 is in there. And then any form of pi, so any multiple of pi, either positive or a negative multiple, are all considered irrational numbers. So that's the breakdown of the two groups that we'll be looking at. And the first key tool that we'll be doing for our checkpoint is to make sure that we can categorize numbers. So when we look at a number, is it going to fall into the rational bubble of real numbers, or is it going to fall into the irrational bubble? And that's what the next activity will be.
Section A, classifying real numbers. Here's the application of the vocabulary that you just learned.
So now we're in our activity A in our notes form. The first thing we have to do is be able to classify real numbers. So we always start with following the directions. It says tell whether the number is either rational or irrational and explain your reasoning. So what's your justification of saying this number is rational? You have to have a reason, or this number is irrational. So we're going to start here. So you're going to have to write this down because these aren't in your notes. We're starting with the radical of 12. So is the radical of 12 a rational or an irrational number? So we have to think about what classifies things. And we know that under a radical sign, we have to see if it's a perfect square or not a perfect square. If you look back at the top of your notes, remember it's in that bulleted point, right, the first one. So is 12 a perfect square? And if I remember, there's no integer that times itself gives me 12. 6 times 6 is 36, and 4 times 4 is 16, and 3 times 3 is 9, so I can't find that number in there. So that means 12 is not a perfect square, so that would classify it as irrational. And what's our justification? Since 12, the radicand, if you remember the appropriate vocabulary for the term under the radical sign, the radicand is not a perfect square. So when you look at something or you justify, when somebody asks you why, you can answer why now. That's your explanation and your reasoning. So if we look at negative 364 thousandths, but we have that bar, and if you remember correctly, that bar is a repeat. So since this number or decimal repeats, what is it classified as? And that's classified as rational. When a decimal repeats, it's considered rational. So it's because the decimal repeats. That's one key fact from the top as well. The next one says negative 1 3/7. Negative 1 3/7 is written as a fraction. And we can change this fraction into what we call an improper fraction that gives us a numerator to a denominator, a ratio. So since we can write it as a ratio, we know that it should be categorized as a rational number. Remember that word ratio is in there. It's A to B in fraction form. And this is rational because it is in fraction form. So again, we need to make sure that I'm really testing you on the first video that you watched, that vocabulary. Do you really understand the difference between rational and irrational? And the last one is 85 hundredths. 85 hundredths, it is a decimal. So to be irrational, it needs to never end and can't repeat. But it did end. It's in the hundredths place. So that means since it terminated, it's considered rational. We can write it as a ratio. We can rewrite that. What can we rewrite that as? 85 hundredths. It's in fraction form. It's a ratio of 85 to 100. So it's in the rational definition. So that means since the decimal terminates. So again, we're really just testing our ideas on those vocabulary so that when we look at any number, we can categorize it and put it in that bubble on that Venn diagram on your notes. Is it rational, and what are the reasons in the, behind that, or is it irrational, and what are the reasons behind that? So now you're going to move on into your checkpoint. You're going to have to copy down the numbers that I'm going to give you, take a few seconds, and complete your checkpoint.
Here's your first checkpoint. Make sure to copy down the 3 examples, complete them, and this is where we're going to start tomorrow's class.